430,000 miles per hour? That's how fast a spacecraft is moving right now, just 3.8 million miles from the surface of the sun. It's the fastest object humanity has ever built, and it's flying through fire. The Parker Solar Probe isn't just surviving inside the sun's atmosphere, it's solving mysteries that have haunted scientists for 80 years. And one of those answers might finally explain why solar storms are so hard to predict. On December 24th, 2024, something unprecedented happened. A machine built by human hands crossed into the corona, the sun's outer atmosphere, and kept going. The probe dove to within 3.8 million miles of the solar surface. For context, Mercury orbits at 36 million miles. Parker got 10 times closer, and it did this while traveling faster than any object in history, reaching speeds of 430,000 miles per hour. At that velocity, you could fly from New York to Tokyo in under a minute. The heat shield faced temperatures exceeding 2,500 degrees Fahrenheit. Behind it, the instruments stayed at room temperature. The engineering is almost absurd in its ambition. But here's what makes this mission more than a technical achievement. For decades, scientists have been baffled by a simple question: why is the sun's corona hotter than its surface? The surface sits at about 10,000 degrees Fahrenheit. The corona, the wispy outer atmosphere, reaches 2 million degrees. That's like walking away from a campfire and finding the air gets hotter the farther you go. It violates basic intuition. It shouldn't happen. In 1942, a Swedish physicist named Hannes Alfvén proposed that magnetic waves might carry energy outward from the sun, heating the corona as they travel. He won the Nobel Prize for the idea, but nobody could prove it. For 80 years, the mechanism remained theoretical. Then Parker's solar probe flew into the corona and measured it directly. What the spacecraft found is something scientists call the helicity barrier. As turbulent energy flows outward from the sun, it doesn't simply dissipate. Instead, it gets trapped and converted into heat in a very specific way. The magnetic field twists, tangles, and releases energy that preferentially heats protons over electrons. This explains not only why the corona is so hot, but why the solar wind behaves so strangely, why it accelerates to millions of miles per hour as it races past Earth. Let that satisfying click of understanding settle in, an 80-year mystery solved by flying a spacecraft into a star. But Parker's discoveries don't stop there. When the probe first entered the corona in 2021, it encountered something unexpected. The boundary wasn't smooth. It was wrinkled, full of spikes and valleys, constantly shifting. Scientists had imagined a clean edge. Reality was chaos. Even stranger were the switchbacks, sudden reversals in the magnetic field that whip back and forth like a flag in a hurricane. These switchbacks come in clumps, far more frequently than anyone predicted. Parker traced them back to specific patches on the sun's surface, where magnetic funnels form. These structures help power the fast solar wind, adding another piece to a 50-year-old puzzle. The man who predicted the solar wind never got to see any of this. Eugene Parker was a young physicist in 1958 when he proposed that the sun continuously blows a stream of charged particles into space. Other scientists dismissed the idea, some called it ridiculous, but Parker was right, and when NASA launched this mission in 2018, they named it after him, the first time a spacecraft was named for a living person. Parker was 91 at the launch. He died in 2022, 2 years before his namesake touched the sun. Right now, Parker's solar probe has completed 27 close approaches. The most recent was March 11th, 2026. Each pass brings the same record-breaking distance, the same impossible speed, the same flood of data from a place no instrument has ever visited. NASA is currently reviewing what comes next. The spacecraft is healthy, the orbit is stable, there's no technical reason to stop, but funding decisions will determine whether Parker keeps flying through 2027 and beyond. What we learn from this mission matters for everyone on Earth. The better we understand how the corona heats up and how the solar wind accelerates, the better we can predict when dangerous solar storms will hit our planet. Every transformer that doesn't explode, every satellite that doesn't fry, every astronaut who gets adequate warning, it traces back to data from a spacecraft smaller than a car, screaming through the sun's atmosphere at 500,000 miles per hour. The universe doesn't care about human schedules or budgets, but for the first time, we're listening from the inside.